This video is for ELEC 1510 Logic Design. This is Lecture 11, Part 2 on decoders, corresponding to textbook section 4.9. Decoders are combinational circuit subblocks that we can use to design lots and lots of different kinds of circuits. Decoders in general have n inputs and 2 to the n outputs. So you can have a 2x4 decoder, that means 2 inputs and 4 outputs. You can have a 3x8 decoder, you can have a 4x16 decoder, and so forth. Decoders have one output for each minterm that can be made up of the input variables. Let's say that we have a 3x8 decoder with inputs called A, B, and C. Output 0 is going to be A prime, B prime, C prime, because that corresponds to minterm 0 made up of variables A, B, and C. Output 1 is going to be A prime, B prime, C. Output 2 would be A prime, B, C prime, and so forth. So this does involve a little bit of circuitry inside the decoder block in order to come up with all of these minterms, but then we can use it to construct all types of additional circuits. A 3x8 decoder block is drawn looking like this. You can see that we have the inputs, the least significant bit up to the most significant bit, and then each minterm as an output. So here we would probably call this A, B, and C, and then minterm 0 all the way up to minterm 7. If we wanted, say, a 4x16 decoder, this would have to be a pretty big block with 4 inputs. So we might call these A, B, C, and D. And 16 outputs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, corresponding to minterm 0 all the way through minterm 15. So obviously minterm 0 inside the decoder subblock would be A prime, B prime, C prime, D prime, and you would have one circuit for each minterm all the way up to minterm 15 being A, B, C, D. So let's talk about how to do circuit design with decoders. These are pretty useful blocks that you can use to design all types of circuits. Basically, if you're given a logic function, to design that with a decoder, you have to expand your logic function into a sum of minterms. For example, let's take the logic function f equals a prime b plus b c prime. We can assume that this is a function of a, b, and c. So we need to add in the missing terms from each product term. So in the first term, we add in c or c prime, and in the second term, we add in a or a prime, and then distribute those to get a prime bc plus a prime bc prime plus a bc prime plus a prime bc prime. We already had this term, so we get rid of it. And this is our function. We have 3 minterms there. And so we can write this function f as the sum of minterms 2, 3, and 6. This is minterm 2, this is minterm 3, and this is minterm 6. So then how we design this with a decoder is we plug in our inputs A, B, and C, and we get at our outputs minterm 0 all the way through minterm 7. So what we need to do is just add together minterms 2, 3, and 6. So I'll draw an OR gate. Minterm 2 enters the OR gate, minterm 3 enters the OR gate, and minterm 6 enters the OR gate. That would be the function f. Now let's say that we have an additional function, because this is a combinational circuit, and our additional function is g equals the sum of minterms 1, 2, 4, and 7. Well, we can use the same decoder block to come up with the output G, which would be the sum of minterms 1, 2, 4 here, and 7. And so as you can see, any function now that is specified as a sum of minterms, we can pretty easily design using a decoder subblock by just taking the minterm outputs and plugging it into an OR gate and creating the output that way. So this is how we'll use decoders to implement functions in this class.